Buenas tardes a todo el mundo. Aquí con ustedes Alberto García, este servidor. Bienvenido nuevamente a Hablemos Cyber, a nuestra reunión mensual de la comunidad de la Fundación Semilla Cyber. Bienvenido nuevamente. Con nosotros tenemos a nuestro invitado especial. Él es Dan Barahona, ya está con nosotros. Vamos a verificar que Dan esté listo y entonces pues comenzaremos al taller
Sí,
que tenemos para hoy. Vamos a verificar. Ok, bueno, Dan, vamos a pasar. Bueno, aquí tenemos a Dan. Dan, how are you
ah,
today?
sí, bueno, estoy bien. A lo mejor puedo empezar por lo menos en español.
Claro que sí. Bueno, ya ustedes tienen una pequeña introducción de Dan, pero Dan, si puede darle una breve introducción a la comunidad de Semilla Cyber que nos está viendo en estos momentos.
Sí, perfecto. Y bueno, ¿puedes oírme y verme? ¿Está bien?
Estamos bien. Voy a verificar aquí. Tengo aquí la comunidad que me está escribiendo.
Sí, espero.
Si hay veo que se está escuchando en el canal, así que no debe haber ningún problema, Dan.
Ok.
Puede darle una breve introducción y la sorpresa que tenemos antes de empezar
Ok,
con el taller.
lo vamos a hacer al principio.
Déjame ver si creo que lo vi. Te
Ok,
digo ahora.
ok, 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 perfecto.
Eh,
Bueno. Am, bueno, gracias Alberto, mucho gusto estar aquí. Gracias por la invitación para hacer otra presentación sobre seguridad de los APIs. Ah, ya puedes ver que español no es mi primera lengua, pero estoy muy contento de estar aquí y conocer a todos. Lamentablemente la presentación va a ser en inglés, pero muy contento de tomar preguntas o comentarios cuando lo tienen o al final. Un poco sobre yo soy Dan Barahona, soy fundador de APIsec University. Es un sitio web que creamos hace 2 años para publicar clases y materiales educativos sobre la seguridad de los APIs. Ha sido muy popular. Ya tenemos casi 90,000 estudiantes en nuestras clases. Todo es gratis. Puedes tomar cualquier clase, lo que quieres, en nuestro sitio. Las clases son muy buenos, muy populares. Puedes adquirir certificaciones y otras cosas en el sitio también. Y espero que te guste esta presentación hoy también. Y Alberto, ¿quieres hacer
sí,
la
claro que sí.
sorpresa?
Veo que Peter se encuentra con nosotros, ya nos está saludando. Peter Narváez. Queremos reconocer a Peter. Peter ayer por la noche, en la tarde, posteó en las redes sociales profesional. Por lo que he visto, pues es un joven profesional que está dedicado a, como decimos acá en Puerto Rico, echar para adelante. Y Peter ha sido, dame válido anoche, que la primera persona que se beneficia de esta beca que otorgamos para la certificación de casa, que es de API, que son los fundamentos en este dominio específico, esta especialización, a través de Cimia Saber y en Puerto Rico. Así que queremos reconocer a Peter en vivo. Ayer lo pusimos en las redes sociales, vamos también a ponerlo en otras redes sociales de la Fundación. Gracias, Peter, por participar, por tomar la encomienda de dedicar tu tiempo a conocer de esta área que es tan importante, que vamos a verlo hoy. Dan va a estar abundando mucho más en base a su experiencia del impacto que esto tiene a nivel mundial. Y Peter, nuevamente, gracias buen trabajo, excelente. Y te tenemos una sorpresa que Dan la va a mencionar ahora. Así que espero que estés escuchando, Dan. Cógete aquí de Next Step
Sí,
to Peter.
el next step. Tenemos más trabajo para ti, Peter. No, estoy muy contento en darte un nuevo challenge. ¿Cómo se dice challenge en español?
Reto.
Tenemos otro examen, se llama ASCP, que es API Security Certified Professional. Es el último examen que tenemos, certificación que tenemos, y con esto tienes que demostrar tus habilidades de hackear, no sé si es una palabra,
Sí.
unos APIs que te vamos a dar, y si puedes encontrar todas las vulnerabilidades, puedes adquirir esta, no sé si puedes ver.
Sí, la vemos. Está...
Sí, muy especial.
Sí.
Happy Hacking y también una certificación. Y bueno, felicitaciones con tu...
O el logro, el gran logro
con
que...
el logro. Y bueno, espero que puedas tomar el próximo también.
Así que lo esperamos, estamos contando en eso, de que ya, Peter, te comprometimos aquí en vivo con Dan, te quisimos dar la sorpresa por el buen trabajo que has realizado, así que te estaremos haciendo llegar luego el voucher para esta beca y esperamos entonces en un tiempo razonable, tan pronto nos dejes saber de que ya lograste la próxima certificación y sea el primero en Puerto Rico de tener esta certificación de pentesting de API.
Seguro.
All right.
Felicitaciones. Bueno, y tengo algo para todos los que están aquí. Tenemos una cosa que todos pueden adquirir hoy día, que es este Certificate of Attendance, certificación de estar aquí y escuchar y aprender lo que vamos a discutir. Y si quedas hasta el final de la presentación, te doy un link donde puedes agregar tu información y te doy un certificate de estar aquí, de tomar esta clase, este seminar, este workshop. ¿Ok?
Okay, así
bueno.
Que ya escucharon, así que se queda al final la misma sorpresa. Pueden tener la parte de educación continua, así que Dan se está votando en el día de hoy con nosotros. Y gracias, Dan, por estar aquí, compartir tu tiempo y tu conocimiento. Bueno, Dan, si estás ready, yo lo que voy a hacer es que te pongo en modo de presentación y
perfecto. Nos vamos. Y ahora en inglés.
Estamos ready. Let's go.
Congratulations, Peter. I'm very excited for you to take our ASCP exam. For people, if you don't know APIsec University, here's a little introduction. You can go to the website. All of these classes are free. We have 90,000 students. Peter, for you, this one on the far left, API penetration testing, that is the class you want to take if you want to pass the ASCP exam. This is very technical. You will learn how to hack APIs in this class. But all of these classes for everyone, they're all free. Anyone can take them. I invite you all. And I hope I will see you in APIsec University. So, today's presentation, it's what I call an API security workshop. And the goal is to raise awareness for you about the risks of APIs and what you can do to better protect APIs. And there's 3 sections to this presentation. The first section is why are APIs under attack? All right, this is what we are going to focus on first. Then we'll go into some real world API attacks, and we're going to examine how those attacks are happening, why they're being successful, what you can do about them. And then in the third section, how do you keep APIs better secured? All right. I'm happy to take questions as we go. I can't see any of you or the screen. I can only see my presentation. So Alberto, please
Yeah.
Let me know if anyone has something they want to share, okay?
Sure.
All right, very good. So why are APIs under attack? And 3 statistics to get us started that really kind of paint the picture. So 83%, that is the percent of the internet's traffic that is API powered. This is from 4 or 5 years ago. Really astounding statistic. It really shows the explosion of APIs, the adoption of APIs. Almost every single website, every application, every mobile app is all using APIs to communicate between the browser or the interface and the backend, right? So this is great. APIs are fantastic technology, and we see this really massive adoption. Okay, that's good. Number 1, though, is where API attacks rank. This is from the Gartner Analyst Group. It was a prediction that by 2022, API attacks would become the most frequent attack vector. That is definitely true, right? You'll see this in the stats, in the examples. APIs are very, very good targets for attacks. They're very successful. And 4% kind of represents the state of API security, which is frankly quite poor. This is a survey that Rapid API did. They have over 1 million users, and they asked the community, what kind of testing do you do on your APIs? And 96% of the response was, we test for functionality, for bugs, for performance, for integrations, for all of these, productive things. And way down at 4%, it was security. Okay, that number is way too low. And there are reasons why it's so low, right? We still test APIs very infrequently, not very well, by hand, with minimal tooling, right? We haven't really done a good job of securing our APIs. And if you look at these 3 statistics together, it makes a perfect environment for breaches. But why are APIs so appealing? What makes them so attractive for attacks? And if you just think about what is an API, it's an application programming interface, right? It is the glue, the connective tissue. It is the plumbing that connects all of our functionality, our UIs, our front ends, to all of that back end data and infrastructure and logic and functionality and so forth, right? This is what makes it all possible. Every time you log into your bank account, there's an API call. If you want to check your balance, that's a different API call. If you want to transfer money from one bank to another bank, right? Those 2 banks are communicating through APIs now. APIs power everything. And if there are any flaws in how your APIs are set up or the logic that sits behind those APIs, that can turn into vulnerabilities. And that can be exploited by users or by attackers. And there is often this belief that APIs are invisible. It's this part of the internet that no one can see, and therefore we don't have to worry about it. We don't have to secure it. I want to make sure you know that is not true right up front. In fact, it's extremely easy to find APIs. You can see here, APIs hiding in plain sight. So here I just went to United Airlines. It could have been any website, really. And I checked some airlines, some airfares and times and so forth. Now, this website is checking the back end for flight times, for flight prices and schedules and all of that kind of thing. And if I want to find the API calls, all I have to do is right-click on the browser, click on Inspect, look at the Network tab, and there you go. There's the APIs. There's one called Fetch Flights. And this is not bad. This is not wrong. This is how the internet works, right? So these APIs are quite visible if you know even basic knowledge of how it works. And your attackers certainly know these APIs are visible, and they're going to attack them, right? So don't think they're hidden and therefore secure. They're very, very visible. And let me show you how almost every API attack happens. So here you have your front end, the mobile app, web app, it's communicating through APIs to the back end where the data and the transactions and the engines live, okay? Now, we have this yellow box around the front end, and that's because the front end is very locked. It's a controlled environment, right? It's where we authenticate users, we filter data, we do all of these things. And I, as a user or an attacker, I can only perform the functions that you allow me to do, right? If there's no button for it, I can't do it, right? So this is a very locked and controlled environment. Now, what your attackers will do is they will come to your applications and they will utilize every feature of it. And then they will identify the APIs like I just showed you. They will watch all that traffic and they will identify all the APIs that are sitting behind the front end. And then they will go around the front end and they will go straight to the API, which is not a controlled environment. In fact, it's quite uncontrolled, right? An API it's one person described it to me, it's a website for machines, right? And instead of having a GUI, right, where I can point and click, it's just a command line and I can type any request that I want and send it. And if it's a good request, it should get processed. And if it's an attack request, hopefully your application can detect it. And often it won't, because what they find at the API often are APIs that are over permissioned, right? Have more access than you want to give to the end user, access to data that the end user shouldn't see, access to functionality end users might not be able or should not be able to use. It can expose logic flaws in the back end that cannot be exploited in the front end. This is the number one reason why APIs are under attack. It is such a ripe target for breaches, right? And if there are any of these flaws that I described that exist at the API, they can turn into vulnerabilities. And so we will give you some examples here, but just to sort of reinforce, like even the lawyers, the regulators, the auditors, they are now very much concerned about APIs, right? If you take credit card transactions, you have PCI compliance. It has a lot of API requirements. If you have personally identifiable information, email, first name, home address, banking information, then GDPR and HIPAA and all of these privacy initiatives will matter to you, right? And your APIs will be covered by that. If you're a publicly traded company, if you are a car maker or you supply the automotive industry, there's a United Nations regulation for that. If you sell to the government, different regulation. So the auditors are very much paying attention. And in fact, this is about 2-3 weeks ago, the Federal Communications Commission just completed an investigation of Verizon and TracFone, where they found an API leak and subscriber data was being exposed through this API for years. And they fined TracFone and Verizon $16 million for that failure, for that exposure. And they set a list of mandatory requirements like education, testing APIs, all of these things to reduce risk in the future. So hopefully they will all come to APIsec University and take our courses. So this is why API security, right? Let's now move into what's happening out there in the real world, okay? And what's happening in the real world is lots and lots and lots of API breaches, okay? Every single one that you see here on this screen is an API breach that succeeded, right? And what do I take from this? There's a lot of companies, right? There's a lot of examples. These aren't just like small companies that are not sophisticated, don't have budgets or best technology. These are high-tech companies, and they're losing millions of records, 10 million, 100 million. LinkedIn, the entire 700 million user database was accessed through an open API or a vulnerable API, right? So there's something about API attacks that are getting through the defenses, right? It's getting through the firewall and the detection and the code analysis and all of that. So we need to understand what it is and what we can do about it. So I'm going to take a few of these and we're going to go into detail and examine what happened to them. And we will take those and we will map them to this list. This is the OWASP API Security Top 10. I imagine a lot of you may have heard of OWASP, Open Worldwide Application Security Project. It's a nonprofit. They produce fantastic guidance on web application security, and they made a special top 10 just for APIs, which is what you see here. And if you want to learn more, just like Peter did, you can take our OWASP top 10 course, and then you can take our CASA exam, Certified API Security Analyst exam. And Alberto, I will be happy to donate some of these vouchers for your community. So I encourage you all to come and learn more. But I like to teach with examples. So let's go through some examples. And the first one is probably the best, the most eye-opening example. And this is Coinbase. Okay, so Coinbase is a crypto marketplace. If you want to buy and sell Bitcoin, this is where you can do it. So here there was a hacker. They wanted to poke around Coinbase and see if they could find any vulnerabilities. So like a good hacker, they went to the homepage. They utilized every feature and function. They created an account. They deposited some money, started trading, and they watched all the traffic, and they found all the API calls. And what you see here in black is what the traffic looks like when you do a trade, right? You see in yellow, we have the parameters of the trade, right? The base size is the quantity. You see the price. The product ID is what they're selling. In this case, it's Ethereum on the European market. They're on the sell side. You see source account, target account. This is what a trade looks like after you hit submit and it goes over the internet. So he wanted to send a ridiculous request because he wanted to see error messages coming back from the server. And by the way, there's a bit of background noise. If someone can go on
Yeah.
mute.
Yeah, well, they are listening.
Oh, okay. No
yeah,
worries.
Yeah, they are not.
Not a problem. So a lot of times what hackers do or attackers is they send ridiculous requests to get error messages because the error messages can be very revealing, right? What type of database, what type of parameters. So he took this request, which was a valid request. He owned Ethereum, right? But he wanted to get an error message. So he backspaced over Ethereum and wrote Bitcoin instead, which he did not own. And he hit submit and he waited for the error message. But he didn't get an error message. What he got back was a trade confirmation. And what you see here is his $1,060 of Ethereum sold as $43,000 as Bitcoin. And just like that, he made over $40,000 profit, right? Without doing anything. And at this point, he probably thought he was going to prison. And instead, he went onto Twitter and said, does anyone know the CEO's email? Because this is potentially market nuking, right? You can go look this up. And Coinbase did a great job. They immediately shut down the market for 24 hours while they identified the issue, fixed the issue, reproduced it, and got back live. And then they explained what happened in a blog post, which you can also find. And they said the root cause was they had a missing logic validation check. And what that means was their brokerage API was checking, does this guy own 0.024 units? Yes, he was. He did own it. But it was not checking what he owned. It just wanted to make sure he had 0.024 of anything. And it did not check what type of asset he owned. And it went ahead and processed it. This is a logic flaw, right? What should have happened is they should have checked the quantity and the asset type before performing this or executing this trade. And so the takeaway, the pro tip here is your UI is not part of security, right? This attack could never have been done in the UI. There's no button to change my Ethereum to Bitcoin, obviously. But at the API, you could do it. And the backend did not have the logic to detect that and block it, right? So that's a classic example of a logic flaw. The next example I want to give you is from Peloton, right? So these are those exercise bikes. So there was another hacker who poked around, found all these API calls on Peloton. And one of these APIs was left wide open, which means you could query it with no credentials, anonymously, no passwords. And this particular endpoint had access to the entire Peloton user database. 4 million users worth of data was accessible through this open API. Well, when this attacker found that, they notified Peloton, said, hey, you are leaking all your customer information. And actually, honestly, it took Peloton months to even pay attention to this. But eventually they fixed it, right? And what did they do? They locked down that API. So you can no longer query it anonymously. You have to have a valid username, valid password if you want to access this record. Well, anybody can go create an account on Peloton and use those credentials and use this API, and you still could access 4 million users' records. And the pro tip here was Peloton, they fixed one thing, which was authentication, but they missed on authorization, right? Authentication is Dan, right? But authorization is, can Dan access Alberto's records, right? And clearly I should not. And that's what they got wrong. And this is what OWASP number 1 is all about, broken object level authorization. You'll hear it called BOLA. The classic example is, can user A access user B's data, right? That's what happened at Peloton. At Coinbase, can I trade Bitcoin that I don't own? That's an authorization flaw, right? They should have checked before running that, executing that transaction. So that's OWASP number 1. OWASP number 2, the example is Duolingo. I imagine some of you are Duolingo users. I'm a Duolingo user. My kids are. So they leaked 2.5 million records through an API, right? So again, hacker poked around. They found all the APIs. They were unlocked, so anybody could query them anonymously with no credentials. And if you supplied an email address to this API, it would respond back and say, is this a Duolingo user? And all of their profile data. So when this became public, I went and I hacked myself. And this is what happened. I'm not even very technical, so you could even do it from a browser. You just go to that URL, you put email equals your email. And this is no unmodified data. I didn't change anything on this screen. That's my actual email. This is exactly what came back. You see my streak, you see what I'm learning, all this information about me. I could have put my email address, your email address, Alberto's, Michael Jordan, anybody's email, and it would still respond to me, right? So why would you leave an API like this open to the wild? Well, this goes back to that myth that APIs are hidden, invisible, and no one's going to find them. And in fact, attackers are looking for these APIs for exactly that reason, right? So don't believe your APIs are secure. And this is a good example of OWASP number 2, broken authentication, right? So weak or poor authentication, no CAPTCHA, no two-factor, short password. But actually, I never see those problems. What I see is no authentication, right? APIs that are left wide open. The door is unlocked. Anyone can use it. You saw that at Duolingo. You saw it at Peloton, and you will see more examples of that. But that's OWASP number 2. For number 3, the example is Venmo, right? This is a payment platform. It's kind of social. So they had a feature on the homepage that would show you the last 10 or 20 transactions in real time. But of course, they would anonymize the data, right? So if it had my first name, it would not have my last name or anything else like that, right? But as you see here, this person scraped millions of Venmo payments. It was a public API endpoint with no authorization needed. So again, API is unlocked. It's unsecured, right? But here's the key. When this attacker queried the API directly, it did not return anonymized data. It returned the whole record, every field of that transaction. And so they knew they had hit a gold mine. So they wrote a script, and they probably took months to do this. And then they harvested 207 million transactions out of Venmo in complete detail. And the pro tip here is, do not filter data in the UI. You have to filter data at the source, at the API layer. In banking, there's this concept called data minimization. You want to return the bare minimum of information to satisfy that use case and nothing more, right? So this is an example of OWASP 3, broken object property level authorization. I find that a very complicated title. In 2019, in the first version of the top 10, they just called it excess data exposure. And that's what this is. We have an API returning way too much information for the use case, okay? So that's number 3. For number 4, this is from just January. This is Trello. So it's a lot like Duolingo. So what happened is if I want to invite you to my Trello project, there's a feature for that, right? I give Trello your email address and some backend process will send you an invitation to my Trello board. Well, that backend process is powered by an API, and that API was also left unsecured. It's open to the world. Anybody can query it. So if you supply an email to that endpoint, it will reply back and tell you, is this a Trello user? And all of the profile data about that user. Username, full name, email, account information, all of that was available in this API. So this attacker found it, and they knew this was valuable. So they went onto the dark web, and they collected 500 million email addresses from other breaches. And they sent 500 million requests at that API to look for matches. And as you can see here, this is the posting on the dark web where they're putting that data up for sale. They found 15 million emails or 15 million matches, 15 million Trello accounts. And they were able to harvest all of that information from it. So what's amazing about this example is 500 million requests, right? And we know that Trello / Atlassian were doing rate limiting and web app firewalling and all of that, right? But that did not prevent this massive amount of data exposure, right? So this is a good example of OWASP 4, unrestricted resource consumption. Anytime we see huge volumes, millions of records, it suggests that our bot defenses, our rate limiting, are not preventing these types of attacks. And the reason why is your attackers know you're doing rate limiting and bot detection. And so what do? They keep their requests below a certain limit, and they can leave it there for months, right? They distribute across thousands of IP addresses, and they use residential proxies and all of these things to evade detection. Okay, so what did Trello do as a response, right? It wasn't to make the rate limiting more restrictive, right? Because that eventually is going to impact legitimate traffic. As you can see here in yellow, what they did was they made a change so that unauthenticated users could not access that information of other users. What that means is if you want to use that API, you have to be authenticated. Okay, and it's way easier to detect abuse of 500 million requests from Dan than 500 million anonymous requests. So simply by taking that unlocked API and locking it, they were able to mitigate this risk. All right, let me give you just 2 more examples before we'll move forward. This one is from Bumble, which is a very popular dating application, 100 million users. They kind of got it all wrong, honestly. Unsecured endpoints, they had BOLA, so user A could access user B and all 100 million users, excess data exposure, exact location, and so forth. But what makes this OWASP 5 is they also exposed functionality that end users shouldn't have, and that's what's called broken function level authorization. So in Bumble, they have 2 types of users. They have a free user and a paid user, right? So they exposed a feature in the API that allows a user to check what type of account they have. That's a GET request. And this GET request is allowed you to say, hey, Bumble, what type of account do I have? Do I have a free or a paid account? That's fine. But they also exposed a post function, which means not only can I get my account, I can also change my account type. And that is not something an end user should be able to do on their own. The only way I should get paid status is if I give you my credit card and some backend process elevates my account. But that feature was also exposed, and this user could change anybody's account from free to paid. That's broken function authorization. And the last example I want to give you is from Instagram. So this one's quite impressive. If you wanted to take over anybody's account, let's say you wanted to take over Taylor Swift's Instagram account, here's how you could do it, right? You would go to Instagram and you would say, I'm Taylor Swift and I forgot my password. And it would send a 6-digit code to the real Taylor Swift, right? So 6-digit codes, that's between 1 and 1 million, right? Well, it turns out there's an API where you can submit your guess, right? So, all right, I can write a script that will easily just start at 1 and go all the way to 1,000,000, and somewhere in between, it will find the right code. But there were some protections, right? Number one, there was a 10-minute timeout, but that's plenty of time to do 1,000,000 API calls. And there was a 200 guess limit, right? So at this point, I think the attacker thought they were done. It wasn't going to work. But they tried one last thing, which was they changed their IP address. And surprisingly, it gave them 200 more guesses. And as long as they kept changing their IP address, they would get 200 guesses for each one. So they could easily create an IP address farm. They could rotate IPs rapidly, do 200 guesses per, and get through all 1,000,000 combinations and take over anybody's account on Instagram. And this is OWASP number 6, unrestricted access to sensitive business flows. It's a really important one because it introduces the concept of business flows or business logic, right? And typically we as operators and developers, we tend to think about how our applications are supposed to work. And in this case, it worked just fine, right? If I forgot my password, there's a perfectly good flow, a workflow to reset my password. The problem is this feature, this business flow was poorly designed, and it allowed an abuse to happen. Right, I could brute force these reset codes and take over someone's account. Right, so we have to think about our business flows not just as they're meant to be used, but how they could be misused and abused. In the case of Instagram, many things they could have done differently. Number one, IP address is irrelevant; should never be part of the equation. Number two is 200 guesses is way too many. Right? Give the user 4 or 5 and then expire the code. It's no longer valid anymore. You have to request a new one. And number 3, which is probably the best, is do not use incremental IDs, right? By making it a numerical ID, right, the reset code, you are basically saying, hey, attackers, the reset code is between 1 and 1,000,000. Good luck, right? If you make it alphanumeric, it's now impossible to iterate, right? So do not make life easy on your attackers, right? Make it difficult. Don't use incremental IDs wherever you can get away with it. So that's number 6. In the interest of time here, we will skim through the rest. Number 7 is server-side request forgery. The idea here is, can an attacker trick your server into going somewhere malicious, right? Like to a malware site or to reveal, user information or something. A simple example here is, imagine you ask a user to provide their LinkedIn profile URL, and instead of giving you a LinkedIn address, they give you a malware site or a SQL injection string or /localhost user data or something like that, right? If it doesn't start with linkedin.com, you got to throw it away, and that's called input validation, right? Make sure you don't trust anything that's coming in. You check it, and if it doesn't look right, you throw it away. Don't use it. Number 8 is security misconfiguration. This is kind of like the standard best practices, like patching and hardening, turning off services, using encryption, using rate limiting, not being revealing in error messages, all of that kind of stuff. We have a course called Securing API Servers that goes into detail here. 9 is improper inventory management. This is really all about, like, you got to know what APIs you have if you want to secure them. And the classic example here is, let's say you had generalmotors.com/API/v3. Okay. When an attacker sees that, they're for sure going to try v2 and v1, right? And a lot of times those old versions, they stick around and they aren't as secure and they have outdated endpoints and they're no longer tested and all of these things. So for improper inventory, make sure you know what APIs you have and that they are fully secured, right? And number 10 is kind of the reverse, which is unsafe consumption. So if you're using APIs from another provider, like DocuSign, Salesforce, Venmo, whatever it might be, don't just assume those are secure and safe, right? You got to do the same testing, the same validation, the same everything on third-party APIs as you would do for your own. Okay, So that's section 2. I know I covered a lot of information, a lot of examples. We went through the whole OWASP top 10. Again, if you want to learn this on your own, at your own pace, I recommend our fundamentals course and our OWASP course. But let me go to the third section of this topic. And Alberto, while I take a drink, any questions or comments from the group?
No question yet, Dan.
Okay, all good.
Yeah, I also shared the link to the OWASP top 10 for API and
Great.
also the link for the APIsec university courses for everyone.
Awesome. Thank you, Alberto. Appreciate that. So so at this point, you understand why APIs are under attack, and you've seen a lot of examples, right? And the different types of threats that APIs have. So the next section is really like, what can we do, right? And there's actually a lot we can do, right? And in terms of securing APIs from a technical perspective, there's really 2 approaches, right? There's testing and monitoring, right? Testing is it's a proactive approach. It's preventative. It's kind of like going to the doctor, right? You want to hack your own APIs before anybody else can. You want to test and run all of these simulations to see where you have vulnerabilities, where you have logic flaws. And if you do this well, this can be a very, very effective way to find vulnerabilities before they ever make it into production, right? So this testing should be done in pre-production. It should be continuous, not once a year. It should be on every release. So that's testing, and we'll do a little more. We'll dig into more detail there. On the other side, you have monitoring, right? This is fundamentally a reactive approach to security, right? Our APIs are live, they're in production, they're accessible to all the good people and bad, right? And typically, this is done by a web app firewall or a SIEM or any of these kinds of technologies. But what we saw already is, Trello and Venmo and Peloton, they all had these detection tools, and somehow the API attacks got through. So you should do, WAF and SIEM and so forth, but don't expect it to block every attack, right? Because there's something about API attacks that's getting through, and we will examine that here in a second. But back to testing. So testing, the vast majority of testing that we do, as I mentioned, is positive testing, right? Does the app do what it's designed to do, right? Like, can I sell Bitcoin that I own? Yes, right? Can I access my records on Duolingo? Sure, right? But down here at 4% is, does it not do what it shouldn't do? Like, can I sell Bitcoin I don't own? Or can I access Alberto's Peloton records and Trello records and take over, Taylor Swift's Instagram account? That's security testing, right? And we don't do nearly enough of it, right? And here's some ideas for what kind of testing I recommend we be doing. 3 categories. At the lowest level, security testing, which is, do we have unsecured endpoints, right? We saw so many examples of the door being left unlocked, right? Peloton and Duolingo and Venmo and Trello, right? Those were APIs left wide open to the world. You could query them with no credentials, right? So make sure you're testing for that. Incremental IDs, right? We saw this at Instagram, right? Just making life easy for the attackers. Injections and cross-site scripting and fuzzing, all these kind of common vulnerabilities. We should run those. Then you've got data-oriented tests, right? So like, what kind of data does my API access? What kind of data is it returning? Is it too much data? Is it sensitive data? Is it compliance? Is there intellectual property, right? So look at how your APIs are accessing data and make sure that's appropriate and properly controlled. And then the third tier of testing is logic, right? So this is probably the hardest thing to do, right? But object ID manipulation, like Coinbase, right? Changing your Ethereum into Bitcoin, right? Cross-account access, like we saw at Duolingo and Trello or Peloton, right? Where I could access other people's records. Or function abuse, right? Like at Bumble, right? Where they took their free account and they made it a paid account without making any payment, right? So this gives you a feel for the types of testing we should be doing. And the reality is you are not going to achieve this by hand, right? There's too much to cover. and developers keep pushing out new code, more features, more functionality every week, every day, every hour, right? You cannot do this by hand. What we need is automation, right? Automation in terms of creating the test coverage, automation in terms of running continuously on every release, shifting left into pre-production, and so forth. So that's the testing challenge, right? And I will have some recommendations here in a moment. The monitoring challenge is a different one. And the fundamental problem is that with API attacks is that they look completely legitimate. That's the problem. And I'll give you an example here. So the first example, get API user ID equals blank or 1 equals 1. Okay. I didn't know this until a couple of weeks ago. This is a SQL injection attack. Why? You see that 1 equals 1? This is basically saying, give me all user IDs where 1 equals 1. Well, 1 equals 1 for me equals 1 equals 1 for Alberto, for Peter, for everybody, right? So if you're vulnerable to a SQL injection attack, this request will result in a full user database dump, right? Now, this is pretty obviously malicious. You can see that or 1 equals 1. Any web app firewall on the planet will block this. It's very clearly bad, right? There's nothing right about this request. It is a classic SQL injection attack, and your firewall will 100% surely block it, okay? But look at the next request. It's a request from user 10 to delete transfer number 123, okay? There's no weird or 1 equals 1 hanging off the end of this. This looks like a completely normal request, right? It's a valid user. They're authenticated. Delete is a supported request. Transfer ID 123 is a valid transfer ID, right? There's nothing weird about this. But guess what? Transfer ID doesn't belong to user 10. It belongs to user 11, right? Your WAF, your web app firewall, has no way to know that. Right? That's a level of context that it does not have, right? And so this request will go through, right? Even though it's completely malicious, your defenses won't know the difference. And this is the key reason why monitoring cannot block every type of attack, right? And if you think about it, your firewall, you're giving it 2 milliseconds to make a judgment on whether this is valid or not. Right? There's not time. There's no way to get that context to know whether this is a valid request. So this is the problem with monitoring. So we have to complement our existing, firewalls and monitoring tools with better testing. So let's dig back into these breaches, because what we wanted to find was, are there any patterns of attacks here, right? And in fact, there very much were. Right. And what you see here is the top 4 items here dominated how APIs get breached. Right. Number 1 on the list is rate limiting. Right. Almost 70% of these breaches involve some kind of high volume data exfiltration. Right. And that might make you conclude that the number 1 thing that we need to improve is better rate limiting or better bot detection. But I actually think that's the wrong conclusion, right? What this is showing is those technologies are easily evaded. Like a determined attacker is going to find their way past your rate limiting defenses. They can distribute, they can stay under the radar, they can take months at a time. And this is not even the core issue anyways, right? The core issue is not rate limiting. The core issue is you have APIs revealing something of value. Right? Like take Trello. If they didn't find valuable information there, they wouldn't have tried 500 million requests. They wouldn't have even tried 50 requests. They'd be like, nothing valuable here. Let's move on. Try something else. So if it's not rate limiting, then what is it? And it turns out these next 3, which are OWASP 1, 2, and 3, were responsible for 90% of the breaches on that last slide. And this was extremely shocking to me when we ran the numbers. These 3 things are dominating how APIs get breached, which means if you can address OWASP 1, 2, and 3 very comprehensively, you have defeated 90% of the attack types, right? And what are we talking about? OWASP number 1, can user A access user B's data? That's what That's the classic example. OWASP number 2, broken authentication. Are we leaving the door unlocked on our APIs, right? Go test every door and see if they're unlocked. And number 3, which is critical, data exposure. Is there something valuable in this response, right? If you think about like Duolingo, if I was to query that API and get my data back, that's okay. That's me. I'm allowed to see my data. But if I was able to query that API and get Alberto's data, which is OWASP number 1, now I have a breach, right? So if we can address OWASP 1, 2, and 3 comprehensively, we have dramatically improved our API security. So, as I mentioned, we have to complement the detection capabilities, the blocking capabilities with better testing. So here is a simple graphic to kind of show you the different approaches that exist for testing. On the vertical axis, you have kind of attack complexity or vulnerability complexity. So at the bottom, common vulnerabilities, SQL injection, cross-site scripting, buffer overflow, these kind of like standard run-of-the-mill vulnerabilities that have been here for years, right? And then at the top, complex vulnerabilities, right? Logic flaws, authorization flaws, these types of things. And then on the horizontal, you have automation level. So is it highly manual once a year, or is it fully automated continuous assessment? And down here at the bottom, these common vulnerabilities, we have lots of technologies, right? We're doing a good job here. Nobody gets breached by a SQL injection attack anymore. That's not a thing, right? We have good technologies. They do a great job of scanning our applications. This is not a problem, right? The problem is at the top, right? These complex vulnerabilities. These are not common. These are unique to you, right? So the classic tools, a Nessus scan is not going to find a Coinbase vulnerability ever. It's not going to happen. So what do? We do pen testing, right? So we hire teams of people to come in once a year and do their best on APIs, right? In many cases, their best is not that great, right? APIs are very hard. They're very complex. They have a huge footprint. And even if they were doing a good job, it's a one point in time, right? And next week, you're going to release more code and it won't be tested, right? So this is the security hole, right? We have APIs that are going live, untested for months at a time, and we're not finding these types of vulnerabilities. So I'm missing the slide here, but I'll just describe it to you. A lot of people will now ask me, like, what kind of tools are there, right? You've pointed out where the hole is. So there's a new category of technologies out there. You might have heard of Postman or Burp Suite, or OWASP Zap has a technology that does more sophisticated API testing. We have our own at APIsec University, APIsec Scan. It's a free tool, free utility. You can try it out. But the main point is we need better, more comprehensive, more automated testing on our APIs if we're going to address this hole. I'm going to skip this slide because it's not really relevant for today. And this is my last slide before I'll get to the thank you. Some of the common things that we see a lot when we do these workshops with organizations. Here you go. Number one, over rotation on discovery. So a lot of organizations are absolutely fixated on discovering every API that exists in their environment, which is fine. There's nothing wrong with that. But I have heard this many times. We're going to do discovery this year. We're going to do testing next year or something like that, right? If you know the front door of your house is wide open, right? Are you going to wait until you check every other door in your building before you lock the door? No, of course not. That's what we should be doing with our APIs. Yes, you should discover everything, but the stuff that's out there, very visible, that anybody can see, make sure you are securing those now, right? We see a lot of incomplete or missing documentation, right? API documentation is crucial for API functionality. It's also crucial for security, right? So we have to make this mandatory in our organizations. Every API gets documented. Lack of standardized processes, right? So whenever we hear about rogue or shadow or zombie APIs, right, that says you don't have standard processes, right? There should be one way that you build and deploy APIs in your organization, and everyone knows it, everyone follows it, right? There should not be random ways for somebody to stand up an API. We see organizations that think they're safe because they ran a Nessa scan on their application. Well, that is not going to find those complex examples. I'm not knocking Nessus. It's great technology. It's been around for 20 years. It's capturing all those low hanging fruit, those common vulnerabilities, but it is not going to capture those more complex, and we have to do better there. Or people who are relying on once a year pen tests, right? Pen testers are still learning all about APIs, so they're doing their best, but it's probably not good enough for what you need. And once a year is not frequent enough, right? If you release code 52 times a year, you need to test 52 times a year, right? So you're relying on this once a year pen test is just not going to give you the coverage that you need. So that is my talk here today, Alberto. Thank you for inviting me once again to be here. Maybe somebody can copy that link there into the chat. That is the link if you'd like to earn a certificate for attending today's session. A lot of people will actually use this for earning their CPE credits because it will show you it will show that you attended and how many hours and all of that nice thing. So, and there's my email address. As Alberto knows, I'm very accessible. You can find me on LinkedIn. Please connect with me and let's stay in touch. If I can ever be helpful in any way, you can please reach out. Please take our courses. We actually are hosting an event on September 25th called APIsec Con for banking. So we're going to have like 3 hours of speeches and talks about banking APIs and how to keep banks secure. If you're interested, it's free, it's virtual. And so I definitely recommend you check it out. And with that, Alberto, let me stop and hand it back.
Ok, no, gracias Dan, muchas gracias por la presentación, muy interesante. Yo creo que tenemos bastante de la comunidad que se ha conectado. No he visto todavía ninguna pregunta. Sí, lo que le mencioné, yo sé que Dan enseñaste lo del CPI, yo de que estuviera interesado me enviara un email, pero estamos bien, seguiremos cualquier cosa.
Sí.
Se pueden comunicar conmigo y le haremos llegar, si alguno tiene algún problema, el certificado de completado para el CPI.
Perfecto, ya.
Dan, yo tengo una pregunta para la comunidad. No sé si tengas una pregunta para los premios y te voy a dejar en esa. Si puedes decir cuáles son los premios y si tiene, cuál sería la pregunta o si tú me dejas hacer la pregunta y vamos quién la contesta.
No sé, no tengo ninguna pregunta preparada, pero podemos hacer uno quizás por email o no sé qué, pero...
Yo tengo una. Vamos a ver si estuvieron atentos. ¿Cuáles son las 3 vulnerabilidades de OWASP Top 10 de API que debemos remediar para prevenir el 90% de los breaches?
Qué bueno. Muy bueno.
El que me diga en el chat ahora mismo tiene que estar presente. Tiene que tener en el chat de presente. Me tiene que decir los nombres de las 3. Y Dan, el que conteste la pregunta, ¿qué se lleva?
Bueno, mucho gusto dar un voucher para el CASA exam, el Certified API Security Analyst. Sí, como Peter logró.
Necesito el nombre. Me están dando números. Me dijeron 1, 2, 3. No, necesito el nombre completo de las 3 vulnerabilidades.
Bueno, es el número correcto, pero ¿cuál es el nombre?
Estaba preguntando nombre. Tenemos aquí Xavier que dice que Broken Authorization, Broken Authentication y dice la última es Data Exposure. Dan.
Sí, buenísimo. Una casa para él.
Ok. Xavier, pues gracias por participar. Te acabas de llevar un voucher para la certificación de casa que ya Peter logró tener.
Buenísimo.
Bueno, iba a mencionar a la comunidad, veremos, estén pendientes a las redes sociales, seguiremos colaborando con Dan. Estamos hablando a ver qué sorpresa traemos presencial a Puerto Rico, así que veremos cuándo, ¿verdad, Dan? Se pudiera realizar.
Me gustaría mucho.
Así
tengo que practicar mi español un poco más.
veremos en eso cuándo lo haríamos.
Sí,
Dan, no es para ponerte en el spot, pero estaría interesante traer un taller de la certificación de Penetration Testing de API. Así que todo lo que nos estén escuchando, la comunidad que esté interesado, me dejan saber en el chat si estarían disponibles para tomar la misma y patrocinamos aquí, hacemos la promoción con Dan para ver cuándo pudiéramos traerle el taller a Puerto Rico para entonces traerlo de API Penetration Testing. Bueno, Dan, entonces, antes de concluir, también quiero mencionar, y voy a un momentito, aquí voy a ponerme en tutorial, quiero mencionar que y lo voy a mencionar a presentar por acá, todo el que esté viendo ahora mismo, para nuestra reunión de septiembre, vamos a tener con nosotros, estamos en colaboración con Hackers Hermanos de Roberto Pimentel y entonces Rafael Pimentel, son los dos hermanos. Ellos estuvieron en DEFCON, en Red Team Village. Roberto con Josh y Kaylin estuvieron dando el taller de cómo hacer deployment de Red Team Infrastructure using Terraform. Muy interesante. No dio el tiempo cuando estuvimos por allá en el taller. Estamos trabajando para septiembre. Roberto va a estar con nosotros, igual que hizo Dan, va a darle su tiempo. Va a darle una introducción a este tema. Y estén pendientes porque estamos trabajando, Dios mediante, estaremos confirmando un taller de 2 días en noviembre. Así que las fechas están pendientes, pero estamos trabajando para confirmarlo, para entonces ser presencial. Así que vamos a estar con Roberto en Puerto Rico, dando ese taller de 2 días, donde usted podrá aprender cómo utilizar Terraform en AWS para desplegar una infraestructura de Red Team para hacer engagements. Así que esté pendiente de las redes sociales, quería dejarlo con esto, así que el que quiera buscar Hacker Hermanos va a estar con nosotros, Dios mediante, si Dios lo permite, allá en Puerto Rico. Y ahora sí, Dan, yo creo si tenemos alguna pregunta antes de cerrar para hoy, de la comunidad. Si no.
Bueno, muchísimas gracias otra vez, Alberto. Siempre alegre estar aquí contigo y la comunidad.
Bueno, Dan, nos veremos pronto, así que vamos a dar por terminado la sesión de hoy. Nuevamente, pregunta, síguenos en las redes sociales, si les gustó. Ok, tengo aquí una pregunta aquí. Dan is watching private companies. Dan, te voy a poner aquí. Tengo una pregunta de Xavier. Me está preguntando que si tú puedes visitar a Puerto Rico para dar talleres a empresa privada, a un equipo de seguridad.
Sí, bueno, yo hago estos, ahí mi perro está ahí. ¿Dónde se fue? Quiere salir. No, estoy muy contento de hacer estas presentaciones. Lo hago unos 2, 3, 4 veces a la semana, virtualmente, típicamente, pero bueno, si necesito una buena razón para ir a Puerto Rico. Sé que mi esposa quiere ir muchísimo.
Yo creo que Xavier, puede ser posible. Nos dejan saber el contenido, ¿ves? Si es que están, como dice aquí, es un security team. Si es para este tipo de taller, un taller más técnico, pues no, te puedes comunicar con nosotros. Yo creo que Xavier tiene contacto mío, así que podemos coordinarlo. Hablamos con Dan cuando podría ser posible, lo trabajaríamos.
Bueno,
Bueno,
suena bueno.
ya hay una invitación, Dan.
Me gustaría mucho, ha sido mucho tiempo.
Ok, bueno, si no veo otra pregunta, ahora sí, nuevamente lo espero, Dios mediante, en septiembre con Roberto Pimentel. Estén pendientes de las promociones que vamos a estar dando en preparación a este otro evento. Y pronto estaremos, Dios mediante, en Puerto Rico, dando un taller que tenemos pendiente, y también el otro taller que estamos trabajando. Así que nos veremos en línea. Hasta
Muchas
la
gracias,
próxima.
Paul.
Muchas gracias, Dan.
Ok, hasta luego.